In this lesson, we're going to go over complex numbers. You'll be able to demonstrate application of complex numbers by combining like terms, multiplying, dividing, and simplifying in the case where we have I squared. We will be able to explain how to reduce large powers of I. So let's start by defining a couple things. The first thing we want to define is what a real number is. A real number is a rational number or an irrational number. So for example, when we think of rational numbers, let's start there. Rational numbers, if you think the first part there is ratio, so something that could be written as a fraction. So like, for example, 2 is a rational number because you could write that as 2 divided by 1. Another example would be negative 1/3. You could write that as a fraction. That is a fraction. So this is a ratio. And another example would be like a decimal. So like maybe negative 6.5. These are all examples of rational numbers. Irrational numbers, so these are numbers such as square roots. So like, for example, square root of 2. This is a decimal that keeps repeating on and on forever. So since it has no endpoint, this is a irrational number. Another example would be pi. So this number continues on forever. So these are all what we call real numbers. The next thing we want to define is an imaginary number. An imaginary number is the square root of a negative number. So for example, the square root of negative 2 is imaginary because you can't take the square root of a negative number. And the last thing we're going to define is complex number. So a complex number is part real and part imaginary. Complex numbers have the form a plus or minus bi, where the a is the real part and this bi is the imaginary part. Lastly, we're going to define the imaginary unit I. So I is defined to be the square root of negative 1. Then if I squared that, so if I did I squared, then I would also square the square root of negative 1. So if I square that, notice the square and the square root cancel off, so I'd get I squared is negative 1. So this would be negative 1. So I squared is negative 1. So section 1, rewrite in terms of I. So we're going to use the fact that I is the square root of negative 1. So when we rewrite this in terms of I, what we do, so for example, in number 1, we have square root of negative 4. Whenever there's a negative in there, you're always going to pull out a negative 1 because we know the square root of negative 1 is I. So I'm going to split this up as negative 1 times, and then negative 4 divided by negative 1 is just positive 4. So I'm left with 4. So I'm doing negative 1 times 4. And then I'm applying my product property of square roots. So I have a product. I'm going to do negative 1 times 4 underneath the square root. So I split it up as square root of negative 1 times the square root of 4. Now, square root of negative 1, we defined that to be I. So I'm just going to replace that with I. And the square root of 4, we know that 2 times 2 is 4. So this would be I times 2, or better notation would be 2I. So we always like to show the I behind the number. In example 2, same idea. So square root of negative 3. There's a negative underneath the square root, so I'm going to break it apart as negative 1 times positive 3. Then apply your product property of square root. So this would be square root of negative 1 times 3 I can split this up as square root of negative 1 times the square root of 3. Square root of negative 1, we defined that. It's I. So this will be I square root of 3. Or if you'd like, you could say square root of 3i. So either one of these is correct. Just make sure you don't put the I underneath the square root sign. So the next section is adding and subtracting complex numbers. And for adding and subtracting complex numbers, you're just basically combining like terms. So you really know how to do this already, because you should treat I just like you would any other variable. So let me show you some examples. So in example 3, I have negative 7 plus 2 minus 5i. Well, I'm adding negative 7 to that set of parentheses, so I can just remove it. This would be negative 7 plus 2 minus 5i. And then I'm going to combine like terms. So the things without the variable can be added. So negative 7 plus 2 is negative 5. And then I have my minus 5i. And I'm making sure to leave my answer in the form a plus or minus bi. So my I has to come second because this is a complex number. Example 4. Again, notice the sign in between the two parentheses says add, so you can remove the parentheses. So this would be negative 2 minus 7i plus 8 minus 3i, and then combine like terms. So negative 2 plus 8 is positive 6, and negative 7i minus 3i is negative 10i. And then the last example, I have 3 plus 6i minus 2 minus 8i. When there's subtraction in between, think of this as saying like negative 1 in front of that second set. You need to distribute it. So that's going to be the first thing you do. So negative 1 times positive 2 is negative 2. And negative 1 times negative 8i is positive 8i. And then that first set, I'm just going to bring it down. 3 plus 6i. Now combine like terms. So I have 3 minus 2 is 1, and positive 6i plus 8i is positive 14i. And this is how you basically add and subtract complex numbers. It's just combining like terms. So the variables with the I get combined together, and the stuff without the I get combined together. Just make sure that your I term is second. Section 3. Multiplying complex numbers. Again, treat I as if it's a regular variable. So as if it was like an X or a Y. We're just going to treat it that same way. The one difference here, when we're multiplying complex numbers, we are going to replace I squared with negative 1. So anytime you see an I squared, you got to replace it with negative 1. So in number 6, I have 3i times negative 8i. So I'm going to multiply the numbers together. So I'm going to do 3 times negative 8. Then I'll multiply the letters together. So this will be multiplied by I times I. Well, 3 times negative 8 is negative 24. And I times I, remember, you add the exponents. So this will be I squared. Anytime you see I squared, you replace it with negative 1. So I'm going to do negative 24 times negative 1, which is positive 24. Example 7. I times 4 plus 6i. So distribute the I. I times 4 is 4i. And I times 6i is 6i squared, because I times I is I squared. Notice I have I squared, so I'm going to replace that with negative 1. So this would be 4i plus 6 times negative 1. Well, 6 times negative 1 is negative 6. And then we need to reorder this so that it's in the form a plus or minus bi. So the I has to come second. So I'm just going to switch these around. So I'm going to put negative 6 here. And this 4i, there's no sign in front of it, so we could think of it as being positive. So this will be plus 4i. So the I always has to come second. And then the last, example 8, I have 7 plus 9i times 2 plus I. So you're basically just going to FOIL that out like you normally would, but at the very end, you're going to replace I squared with negative 1. So let's look at this one. So I'm going to FOIL. So 7 times 12 is 14. 7 times I is 7i. 9i times 2 is 18i. And 9i times I is 9i squared. Whenever there's an I squared, replace it with -1. That's your first thing to do. Now I have 14. We can combine 7i plus 18i, because those both have an I, so that's 25i. And then 9 times -1 is -9. So now we'll just combine like terms one more time. So 4 minus 9 gets you 5. So this would be 5 plus 25i, like that. So that's your answer for the last one. So basically, whenever you see I squared, you're just replacing it with -1 and then simplifying. So you should never see an I squared in your answer. It's okay to have an I in your answer. You just can't have I squared.